What are you doing here?
I'm here for the abs lab.
I will show you what abs are.
So, what is abs?
It's not ABS, it's ABS. Anti-lock braking system.
But what does it do?
Well, it's a safety design that stops the wheels from locking up.
So, who invented ABS?
Now let me introduce to somebody who knows about the history of ABS.
Hello, I'm here to talk about the history of anti-lock braking system. The anti-lock braking system was developed in 1929 by a French pioneer in automobile, Gabriel Wilson. The first car to have ABS fitted standard was the Ford Granada MK3 of 1985. And also the German firm Bosch has started anti-lock braking technology since the late 1930s. But the first car to use the Bosch electronic system was the Mercedes-Benz and the truck. And later on, the ABS was introduced for motorcycles.
Okay, so now I know about the history of it. How does it work?
Well, to know how it works, first of all, you need to know the basic components that make up an ABS system. So, there's three major things, which are the wheel sensor, the ECU, which is the electronic control unit, and the HCU, which is the hydraulic control unit. And the HCU is made up of the solenoid valve, the accumulator, the fluid return pump, and the pump motor.
Whoa, slow down here. What's a wheel sensor?
The wheel sensor consists of a tooth disc attached to the hub of the wheel and a pickup placed near to the disc. The pickup is basically a horseshoe magnet with a coil around it, and as the disc rotates, the teeth cut the magnetic field, causing magnetic flux linkage, thus inducing a current. So the frequency of the current will depend upon the speed of the disc, and the rate at which the frequency changes will be proportional to the deceleration or acceleration of the disc. This signal will be sent to the ECU, which will be used to determine whether a wheel is about to lock up or not. How long is that?
Okay, a wheel sensor. I know what it is now. But what do the ECU and HCU do?
The ECU is an embedded system that uses readings from the wheel sensors to determine what commands to send to the HCU. If ECU senses a rapid drop in the wheel's rotational speed, it then sends commands to the HCU to either stop braking pressure increasing or, if necessary, relieve brake pressure in order to get the wheels rotating at an acceptable rate. If the rate of deceleration of the wheel greatly increases again, then the procedure will repeat itself. A typical system will be able to repeat this cycle up to 15 times per second.
Now we move to the HCU. This is the main part of the system which controls the brake pressure. And starting off, we'll have a look at the solenoid valve. This is an electromechanical valve. The valve is controlled by an electric current through a solenoid coil. The armature in the valve will be held in place by a spring when not in use. The armature will be moved by being attracted to the magnetic force of the solenoid when current runs through it. How far the armature moves depends on the size of the current running through the solenoid. The moving of the armature will either open or close the valve, depending on its initial position. The solenoid valve is the main part of the HCU that allows or prevents the flow of brake fluid, thus altering the pressure of the system. This is an ideal type of valve due to it being activated by a current, so the valve can be open and closed many times a second. This allows the ABS to perform much better by the fact that it can stop and reapply the brakes up to 15 times per second.
Now moving on to the accumulator. This stores some of the diverted brake fluid when the brake pressure needs to be relieved during the operation of the ABS. It also absorbs the surge that otherwise would occur as a result of the sudden opening of the pressure release valve.
The last of the major components in the HCU is the fluid return pump and pump motor. To get the diverted fluid from the accumulator back to the brake master cylinder in as little time as possible, it needs to be pumped back. The fluid return pump is powered by the electric motor. making its operation extremely quick. Thus, like the solenoid valve, it allows the ABS to complete many cycles per second if required.
Now that we know about the individual components, let's see how the whole system works together. Initially, we're going to have a look at the brake pressure building up, and this involves no intervention from the ABS. When the driver pushes on the brake pedal, the first pressure build-up phase begins. During this phase, no current will flow through the solenoids. Pressure generated by the master cylinder opens the top valve against the force exerted on its return spring. At the same time, the lower valve is held shut by the low return spring. So the fluid from the master cylinder flows through the open valve, down to the duct on the right hand side of the armature and out to the wheel cylinders. This flow also helps force the bottom valve down.
We will now look at a pressure reduction cycle. When the ABS system detects a wheel is about to look up, maximum voltage is applied to the solenoid to lift the bottom of the valve off its seat. This will direct brake fluid into the accumulator and lower the pressure in the brake caliper. At the same time, the upper valve is held closed by the spring and the falling pressure in the return circuit from the wheel cylinder.
Now the ECU will determine if the wheel is decelerating at a suitable rate, and the solenoid valve will return either to its pressure build-up or pressure hold position. Finally, we will have a look at the pressure hold phase. To hold the pressure, only half the maximum voltage is applied to the solenoid. The armature is only lifted halfway up its travel. This provides enough force, along with the spring, to hold the upper valve closed, preventing any increase in brake pressure. The force isn't enough, though, to open the lower valve, so the pressure is held constant.
But how is this going to help me in real life?
Right, Michael, now we're going to look at two real-life examples. First up, we're going to look at the car without ABS. Notice, the car wheels locking up and skidding. Now we're going to look at the car with ABS enabled. The ABS will leave and reapply the brake pressure many times a second to ensure the maximum braking force. This should decrease the braking distance. Also, it will aid the stability of the car, allowing the driver to steer around the obstacle. ABS will help bring the car to a standstill in any condition and upon most road surfaces.
I mean, that was really interesting about anti-lock braking system and everything, but I just want to know how to get good apps.